All right, Algebra 2. Here is part 3 of section 4.5. I used that balancing the videos as an excuse to get some water because I was starting to dry out a little bit from talking a lot. You know, I like to babble on. Um, but here is part C and D of that last example where we're still solving. Okay, so let's go ahead and solve part C. First step, we got to get the squared thing by itself. So we got to get this thing alone before we can square root. So we get x minus 2 squared plus 2 equals 0. Let's subtract the 2 on both sides. I get x minus 2 squared equals negative 2. Now here we can square root both sides. Except this is a no-no. This is bad. And the reason why is because, not just because 2 is not a perfect square, but let's take negative 4, for example. What can I multiply by itself to get negative 4? Well, the answer is not 2 because 2 times 2 is positive 4. And the answer is not negative 2 times negative 2 because the answer is still positive 4. So there's no way for this to work, which means, you know, I can't do that. That's not a thing. We get what's called a complex number, and we'll talk about that in section 4.6. But for now, we're just going to say this, since this is not a real number, there is no solution. So for now, no solution. Okay, and that only applies to 4.5. Once we get a 4.6, there will be a solution, but that can wait. So let's do the last example. Get the squared thing by itself. So let's add 1 to both sides. 2x plus 3 squared is equal to 10. We're still needing to get the squared thing by itself, so let's divide by 2 on each side. Notice we can't distribute this 2. That's not allowed because this squared is trapping x plus 3. Order of operations says I need to square this first, but why square it when we're about to square root it? Okay, so the easiest thing to do here is get rid of the 2 by dividing it over. X plus 3 squared is equal to 5. Now here I have the squared thing by itself. It's okay if it's an x plus 3. We're going to see how to deal with that in a little bit. Let's square root both sides. Plus minus. Square root undoes the square. I'm left with x plus 3 is equal to plus minus square root 5. Square root 5, I can't simplify that, so it stays like that. And then my last step here is to subtract 3 to finally solve for x. And the way you would write this up is x is equal to, usually you do your whole number first and then your radical. So negative 3 plus or minus rad 5. 2 answers. One of them is negative 3 plus rad 5, and one of them is negative 3 minus rad 5. Just like the ones from above, okay? 2 answers here. One of them is positive 2 rad 3. The other one's negative 2 rad 3. One answer is positive rad 35. The other is negative rad 35. Okay, so you'll almost often have 2 answers or no answers. And there are some cases where you just have 1, but we'll look at that in a little bit. Okay, let's do an application problem. When an object is, we're going to need to define an equation really quick. Sorry, I didn't mean to jump in immediately. When an object is dropped mid-air, its height, h, in feet, t seconds after being dropped is given by this function. H of t is equal to negative 16 t squared plus h sub 0, or you can just call it h0. Most people call it, or sorry, when you get into like physics and higher level math, it's actually called h naught, not as in not, but you can just say h0 for now, where h0 is the initial height of the object. Okay, so we're going to use this equation in our last example. For a science competition, students must design a container that prevents an egg from breaking after dropped from a height of 50 feet. So we're dropping it from 50 feet. Ignoring air resistance. Oh, that's another thing. This is ignoring air resistance, no air resistance. And you're probably wondering, well, Mr. G, how is that practical? Everything has air resistance, right? Most things, yeah. And it's not very practical, especially since a lot of things have air resistance. But for the sake of this problem, we're going to ignore the air resistance, okay? How long does it take for the container to hit the ground? So let's use that function. H of t is equal to negative 16 t squared plus h naught, which is our initial height. What's our initial height? 50 feet. So I can just immediately replace it with 50. Okay, so we're figuring out how long it takes for it to hit the ground. Well, if h is height, what am I going to substitute for this h of t? On the ground, my height is 0. 0 is equal to negative 16 t squared plus 50. Hey, we've solved this stuff already. Let's go ahead and do that. Get the squared thing by itself. We're going to subtract over our 50. So we get, we're going to switch it as well in one step. Negative 16 t squared is equal to negative 50. Divide over negative 16. When we do that, we get t squared is equal to positive. It's exactly actually 3.125. And then let's go ahead and square root both sides. Now you need to just put the plus minus here, but knowing t is time, so really I'm only going to care about the positive. I don't care at all about the negative because I'm talking about time. Square root undoes the square. T is equal to, this is going to be about 1.8 seconds. Okay, positive. We don't care about the negative because we're talking about time. There's no negative time. All right, hopefully that sounds a-okay to you guys. That was 4.6. We used square roots to solve quadratic equations. We're going to carry on in 4.6 with that idea of complex numbers, taking the square root of negatives, like we mentioned earlier. We're going to see what we can do with that kind of stuff, okay? I'll see you there.